Good afternoon, everyone. Today we have to start miscellaneous exercise of chapter 10. That is vector algebra. We have to do the miscellaneous exercise. So let us start with the first question. Write down a unit vector in xy plane making an angle of 30° with the positive direction of x-axis. See, write down a unit vector in xy plane making an angle of 30° with the positive direction of x-axis. We have to write a unit vector in xy plane. So x-axis and y-axis. Remember, we have to write a unit vector making an angle of 30° with the positive direction of x-axis. So with the positive direction of x-axis, a vector which makes an angle of 30°. You have to find a unit vector along this. See, the component form of a vector is a1i plus a2j plus a3k. If it is a unit vector, the scalar components are a1i plus a2j plus a3k. And if this a is a unit vector, then the scalar components a1, a2 and a3 are the direction cosines. Okay, always remember this one. If the given vector, if the vector is a unit vector, then the scalar components are the direction cosines. And here we have to write a vector in xy plane. XY plane, that means only I, the unit vector along x-axis is I and the unit vector along y-axis is j. So only these two will exist there. And for that, you know that a1 is cos alpha and a2 is cos beta. This vector makes an angle 30 with the x-axis, so it makes an angle 60° with the y-axis. So we can take alpha as 30 and beta is equal to 60°. And a1 equals cos 30 and a2 is equal to cos 60. So this equals cos 30 is root 3 by 2 and cos 60 is 1 by 2. Therefore, the vector is root 3 by 2i plus 1 by 2j. Is it clear? This is the concept we are using here. Since we have to find a unit vector, the scalar components are the direction cosines. Direction cosines means cos alpha, cos beta and cos gamma. Here the angle is given to us 30 degree with x-axis. So its complementary angle 60 degree will be with y-axis. So next one, find the scalar components and magnitude of the vector. Joining the points P x1 y1 z1 and Q x2 y2 z2. Find the scalar components and magnitude of the vector joining the points P x1 y1 z1 and Q x2 y2 z2. So 2 points are given here, P and Q. How can you write vector PQ? What is vector PQ? P is not a vector, P is a point. P is x1, y1, z1. So P is not a vector, it is a point. Q is also a point. See, 2 points are given to you, P and Q. Then the vector joining these two, PQ. How can you write this vector? If 2 points are given to you, how can you write the vector? It is simple, x2 minus x1i, x2 minus x1i plus y2 minus y1j plus z2 minus z1k. Okay. See, the corresponding coordinates you have to take. X coordinates are x2 and x1. So it is x2 minus x1i plus y2 minus y1j plus z2 minus z1k. So the scalar components are x2 minus x1, y2 minus y1 and z2 minus z1. These are the scalar components. So always remember this one, 2 points P and Q are given. That is, the coordinates of the points are given to you. Then to write the vector joining the 2 points is x2 minus x1i plus y2 minus y1j plus z2 minus z1k. Then the scalar components are x2 minus x1, y2 minus y1 and z2 minus z1. So you have to find the scalar components and the magnitude. So magnitude of PQ root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Clear? Okay, now let us move to the next question. Third one. A girl walks 4 kilometers towards west, then walks 3 kilometers in a direction 30° east of north. 30° east of north and stops. Determine the girl's displacement from her initial point of departure. A girl walks 4 kilometers towards west, then walks 3 kilometers in a direction 30° east of north and stops. Determine the girl's displacement from the initial point. So here east, west, north and south. A girl from her initial point moves towards west, 4 kilometers towards west, and then she walks 3 kilometers in a direction 30° east of north. From here, north means in this direction. This one. From here, 30° east of north. 30° east. East direction means this. So it is 30° east of north. 3 kilometers from here. And she reached here. Find her displacement from the initial point. This is the displacement from the initial point. So let this point be P. Let us draw a perpendicular here. This be equal to M. Let this point be I. And this is O. Okay, O is the initial point. From here, 4 kilometers towards west and then 30° east of north. From here 30 degree. So this is 60 degree. You have to find out this displacement. That means you have to find vector OP. To find this OP, this distance gives the x coordinate of P and this gives the y coordinate of P. Okay, the distance OM gives the x coordinate of P and this PM gives the y coordinate of the point P. So let us find that. Cos 60 is equal to, see this is 60 degree, this angle gives 60 degree, so cos 60 is equal to adjacent side by hypotenuse. So it is IM divided by hypotenuse is 3 kilometer and this IM is equal to cos 60 is 1 by 2 into 3. So it becomes 3 by 2. And you know that OI is 4 kilometer. OI is equal to 4. Therefore, OM is equal to 4 minus 3 by 2. And since if we consider this as the coordinate axis, this is the negative part of x-axis. So we have to put minus sign here. Is it clear? Okay, now minus of, you will get this as minus 5 by 2. Taking the LCM, 4 to 8 minus 3, it is 5 by 2. Since it is the negative part of x-axis, negative sign here, so it is minus 5 by 2. Now let us find this PM. PM is sin 60 is equal to PM divided by, that is opposite side by hypotenuse, which is equal to 3. So PM is equal to 3 into sin 60, which is root 3 by 2. So it is 3 root 3 by 2. So the coordinates of the point P are minus 5 by 2 and 3 root 3 by 2. Vector OP is the position vector of the point P. See, vector OP is the position vector of the point P. To write the position vector, it is minus 5 by 2 I plus 3 root 3 by 2 J. This is the displacement. Okay, I hope it is clear to you. First moving from O to I and then 30 degree in the direction east of north. Then we have to find the coordinates of this point P. For that we use the concept of trigonometry. Okay, after getting the coordinates of the point P, OP is the position vector. So to write the position vector, we have to write minus 5 by 2 I plus 3 root 3 by 2 J. Okay, moving to the next one. If A is equal to B plus C, then is it true that modulus of vector A is equal to modulus of vector B plus modulus of vector C? Justify your answer. If A is equal to B plus C, then is it true that modulus A is equal to modulus B plus modulus C? Justify your answer. See, here it is given that a vector A is the sum of two vectors B and C. So let us first write two vectors B. Let us consider an example here. I plus J plus K as B. You can take any vector here. 2I minus J plus K. So you got B and C. Given that A is equal to B plus C. So we can find vector A from this sum of these two vectors. So it is 3I plus 0J plus 2K. See, given that A is a vector which is the sum of two vectors B and C. So we are considering two vectors B and C. Taking the sum of that two, it gives the vector A. Now let us find the modulus of all these three vectors. Modulus of A is equal to root of 3 square, that is 9, plus 0 square, it is 0 plus 4. So it is root 13. Then modulus of vector B is root of 1 plus 1 plus 1, which is equal to root 3. And modulus of vector C is root of 4 plus 1 plus 1. So it is equal to root 6. Is it true now? Is this relation true? Modulus of vector A is equal to modulus of vector B plus modulus of vector C. We cannot add this B plus C. It is root 3 plus root 6. It is not equal to root 13. So this relation is not always true. Okay. So therefore, here modulus of A is not equal to modulus of B plus modulus of C. And this example is our justification. Is there any case in which this equation becomes true? See, now if we consider vector A dot vector A, you will get this as B plus C dot B plus C. Okay, so A dot A is modulus of A square. This is equal to, multiplying these two, you will get it as B modulus of B square, then plus 2 into B dot C plus modulus of C square. So this is one relation, let this be here. Then if we take the square of this, one, modulus of A square will be equal to modulus of B square plus 2 into modulus of B into modulus of C plus modulus of C square. Now compare these two. You can compare these two. If you have to get these two conditions together, see here, modulus of B square, here also it is modulus of B square, modulus of C square, both the terms are common in this. You have to get 2 B dot C is equal to, that is B dot C will be equal to modulus of B into modulus of C. What is the condition for this statement to be true? In which condition you can say that B dot C is equal to modulus of B into modulus of C? Properties of dot product. In what situation you can say that B dot C is equal to modulus of B into modulus of C? What is the definition of B dot C? Basic definition of the dot product. Definition of dot product or scalar product. Give your answer. What is this? How can you define this dot product B dot C? It is BC cos theta, isn't it? Modulus of B into modulus of C cos theta. So this is equal to modulus of B into modulus of C. This, if you have to get this relation, cos theta must be equal to 1. Right? Then theta is equal to 0. So this equation becomes true only when theta is equal to 0. Okay, the definition of dot product is B dot C is equal to modulus of B into modulus of C cos theta. This must be equal to modulus of B into modulus of C. So this happens only when cos theta is equal to 1. Cos theta is equal to 1 when theta is equal to 0. So if you have to say that the relation is true, then theta must be equal to 0. In all other cases, this relation does not hold, or the equation is not true. Is it clear? Okay, now the next one. Find the value of x for which x into I plus j plus k is a unit vector. Is a unit vector. So let us consider the given vector as vector A is equal to xi plus xj plus xk. It is given that A is a unit vector. So what you can write from it? What can you write from this? A is a unit vector. It is given that it is a unit vector. What can you write from this? Unit vector means magnitude is equal to 1. So magnitude of vector A is equal to 1, which implies root of x square plus x square plus x square is equal to 1. That implies 3x square, root of 3x square is equal to 1, or squaring it becomes x square is equal to 1 by 3, x is equal to 1 by root 3. See, it is given that x into I plus j plus k is a unit vector. That means its magnitude is equal to 1. So to find the magnitude, it is x square plus x square plus x square. Root of that is equal to 1. So the value of x is 1 by root 3. Okay. Now the next one. Find a vector of magnitude 5 units. Find a vector of magnitude 5 units and parallel to the resultant of the vectors A equals 2i plus 3j minus k and B equals I minus 2j plus k. I minus 2j plus k. Find a vector of magnitude 5 units and parallel to the resultant of the vectors A is equal to 2i plus 3j minus k and B is equal to I minus 2j plus k. What do you mean by resultant of the vectors A and B? What do you have to do to find the resultant of vectors A and B? Resultant means sum of the vectors, that is A plus B. This is the resultant of vectors A and B. This equals, taking the sum, you will get it as 3i plus j, then plus 0k. Okay, sum of the vectors. See, a vector which is parallel to this one. Let us find a unit vector which is along this A plus B. So it is A plus B cap. Unit vector along this is 3i plus j plus 0k divided by its modulus. Modulus is root of 3 square 9 plus 1. Okay, so this is equal to 1 by root 10, 9 plus 1, root 10 into 3i plus j. This is a unit vector along this. That means the magnitude of this vector is 1. The symbol is for unit vector. So A plus B cap. It means a unit vector along the direction of this A plus B. Now you have to find a vector of magnitude 5. What you have to do? Vector of magnitude 5 which is parallel to A plus B is here. A plus B cap is a vector which is parallel to A plus B with magnitude 1. So you have to write a vector of magnitude 5 parallel to A plus B. What you have to do here? Multiplying this unit vector with 5. So it is 5 by root 10 into 3i plus j. Or you can multiply it with 2 here in the numerator and denominator, then this becomes 10, cancelling this root 10 by 2. Root 10 by 2 into 3i plus j. You can simplify it like that, rationalizing the denominator. Parallel vectors means scalar multiples. So here we are multiplying with 5. Is it clear? So the next one. Show that the points A1 minus 2 minus 8, B 5 0 minus 2, and C 11, 3, 7. 11, 3, 7 are collinear. And find the ratio in which B divides AC. Find the ratio in which B divides AC. Show that the points A, B and C are collinear. What you have to do for this collinearity of points? How can you prove this? First find AB, vector AB. Here coordinates of the point A and B are given. So you can write vector AB as, what is vector AB? Give your answer. AB, vector AB. Five minus 1I, that is 4I. Then 0 minus minus 2, which is 2j plus 2j. Then minus 2 minus minus 8, it is plus 6k. AB is equal to 4I plus 2j plus 6k. Find out modulus of AB. What is modulus of AB? It is root 56. Okay. So this is equal to, this can be written as 4 into 14, or you can write this as 2 root 14. Similarly, you can find BC, vector BC and its modulus. Then AC and its modulus. First find BC. What about this BC? It is 6I plus 3j plus 9k. 6I plus 3j plus 9k. Okay. Now its modulus. Once again check it, Tejas. Modulus of BC. It is root of 126. Okay. Root of 126, which can be written as 9 into 14. Isn't it? 9 into 14. Okay. So it is 3 root 14. And find out AC now. AC. It is 10i plus 5j plus 15k. Okay. 10i plus 5j plus 15k. What about the modulus? It is root of 350. Okay. Root of 350, which can be written as 25 into 14. So it is 5 root 14. Okay, see now. Modulus of AB is equal to modulus of vector AB. AB plus modulus of vector BC is equal to modulus of vector AC. Therefore, A, B and C are collinear. See 2 root 14 plus 3 root 14, which is equal to 5 root 14. See now, A, B and C are collinear, 3 points B and C. AB is 2 root 14. Then BC is 3 root 14. AC is equal to 2 plus 3, 5 root 14. So A, B and C are collinear. Now you have to find the ratio in which B divides AC. What's the ratio? From here you can say the ratio. The ratio in which B divides AC, that is AB by BC, or AB is to BC. It is 2:3. Okay. See, now this is one method to prove that 3 points are collinear, or from here itself you can say that whether this A, B and C are collinear. See, for that you have to find vector AB and vector BC. Only these two required. Or another method, find out AB and BC. You know that the scalar components are the direction ratios. Okay, so here 4, 2 and 6 are the direction ratios of vector AB. 6, 3 and 9 are the direction ratios of BC. So are they proportional? The direction ratios, are they proportional? So for that, let us find A1 by B1, A2 by B2, A3 by B3. Okay, for that A1 by B1 equals 4 by 6, which is equal to 2 by 3. Then A2 by B2 is 2 by 3. And A3 by B3 is also equal to 6 by 9, which is equal to 2 by 3. See, A1 by B1 is equal to A2 by B2, which is equal to A3 by B3. That means the direction ratios are proportional. Direction ratios of AB and BC are proportional. And the ratio here is equal to 2 by 3. So you will get the ratio in which B divides AC is 2:3. See, direction ratios of AB and BC are proportional and B is a common point. Common point. Therefore, A, B and C are collinear. You can conclude the answer like that. Since this is 2 by 3 is a proper fraction, you can say that the common point B divides AC in the ratio 2:3. Is it clear? Okay then. Next one. Let A is equal to I plus 4j plus 2k B equals 3i minus 2j plus 7k and C equals 2i minus j plus 4k. 2i minus j plus 4k minus j plus 4k. Find the vector D which is perpendicular to both A and B which is perpendicular to both A and B, and C dot D is equal to 15. C dot D is equal to 15. Three vectors are given. A is equal to I plus 4j plus 2k. B equals 3i minus 2j plus 7k. 3i minus 2j plus 7k, and C equals 2i minus j plus 4k. Find a vector D which is perpendicular to both A and B, and C dot D is equal to 15. How can you find a vector which is perpendicular to both A and B? A vector which is perpendicular to both A and B. Remember this one, a vector which is perpendicular to both A and B is A cross B. Okay, the definition of cross product. A vector which is perpendicular to both A and B is A cross B. This is one of the perpendicular vectors. So let us find this A cross B. A is given here, B is given, both are in component form. So to find A cross B, find the value of the determinant. 1, 4, 2, 3, minus 2, 7. So if you have to find a vector which is perpendicular to two given vectors, find their cross product. So this equals I into 28 plus 4, it is 32. Then minus j into 7 minus 6, it is 1. Then plus k into minus 2 minus 12. It is minus 14. So A cross B is the vector 32i minus j minus 14k. See, this A cross B is a vector which is perpendicular to A and B. Given that D is perpendicular to both A and B, but it is not sure that D is equal to A cross B. Okay, any vector which is parallel to this A cross B will be perpendicular to A and B. Isn't it? Lines parallel to the same line here. This is perpendicular to A and B. So the lines which are parallel to this will be perpendicular to both A and B. So let us write D as a scalar multiple of this. So it becomes 32 lambda I minus lambda j minus 14 lambda k. Any scalar multiple is parallel to the given vector. D is a scalar multiple of A cross B. So D is parallel to A cross B. That means D is perpendicular to both A and B. Is it clear? A cross B is perpendicular to A A cross B is perpendicular to vector B. See, D is parallel to A cross B. Since this D is a scalar multiple, therefore D is perpendicular to A and D is perpendicular to B. Okay, now it is given that C dot D is equal to 15. In the question it is given that this one more condition is there. C dot D is equal to 15. Let us substitute the values. C is given as 2I minus J plus 4K dot 32 lambda I minus lambda J minus 14 lambda K is equal to 15. So to find the dot product, we have to multiply the scalar components. Okay, so 32 lambda into 2, it gives 64 lambda. Then minus lambda into minus 1, it becomes plus lambda. Then minus 14 lambda into plus 4, it is minus 56 lambda. This is equal to 15. To find the dot product, we have to multiply A1 B1 plus A2 B2 plus A3 B3. So here you will get this as 65 minus 56. 9 lambda is equal to 15, or lambda is equal to 15 by 9, which is equal to 5 by 3. Substitute this value of lambda here. Vector D is equal to 32 into 5. It is 160 by 3 I minus 5 by 3 J, then minus 70 by 3 K. So this is the vector D. Okay, with this chapter is over. We'll start the next one in the next class. New chapter, that is 3-dimensional geometry. In the next class. Okay, thank you for joining.